Hello everyone, I am here again to discuss another topic in probability and statistics. This time it's all about normal distribution and area under the normal curve. This is your teacher, Mr. Mark Anthony B. Laroya. Let's say we were given a particular data set or set of data wherein the values for scores and frequencies can be seen. So these are the scores. Let's say there is an examination containing 25 items or a total of 25 points, and these are the frequencies of the students who took the exam and then got particular scores. Let's say for one, the one who got the score of 1, the frequency is 1. That means one student got the score of 1. For 25, the perfect score, only one student got a perfect score. And then as we see here, at the score of 13, 23 students got 23 points. So this score has the highest frequency. So let's say we graph this data set and then we form a curve. An increasing line or an increasing curve wherein and when it reaches the value with the highest frequency, it starts to decline again. So this data set we can say that this data set is normally distributed, more likely of a bell shape. And this is now what we call normal distribution curve. Let us now talk about the properties of the normal distribution curve. So these are the properties of the normal distribution curve, and this is our normal distribution curve. So it is a bell shape, and the value at the middle is our mean, our median, and as well as our mode. And our normal distribution code is unimodal, meaning in our data set there is only one value that has the most number of frequency, and that is also our mean and the median. The curve is symmetrical about the mean, meaning when we cut this into two vertically, they are just the same. The left side is the same as the value of the right side, and they are like mirror. The curve is continuous. The two tails of our normal curve are continuous, and the curve never touches the x-axis. So that means this horizontal line here serves as the asymptote for the normal curve, and the total area of the normal curve is equal to 1 or 100%. Since they are symmetrical, that means the left side of the curve is equal to 50%, and so as the right side. Let us now talk about the area under the normal curve. Because of the importance of areas under the standard normal curve, tables of those areas have been constructed. A 4 decimal place number in the table gives the area under the standard normal curve between 0 and a specified number or value of z, or the z-score. So this is the table that we're going to use in identifying the area under the normal curve. So it is very important that we must identify first the value of the z-score, because it will be our basis of our boundaries from the mean up to a particular value of z-score. So in this example, this is our curve. At the middle, 0 is the value of our z-score, or this is the mean of our data, and then at particular value of z-score, it will become our boundary, and then this shaded area is the area that we're going to look for using this table. So this is our normal curve, wherein at the middle is the mean, but in this case we are going to use the value of z-score. 0 is at the middle because it is also the mean and the value. So if we're going to get the z-score using your mean as also your x, the value will become 0. So if your z-score is positive, that means your area concerned will be on the right side. And if your value for z-score is negative, that will be on the left side. So these marks here, as well as here, are actually values of your z-score. So that means from the mean up to this mark, the value of your z-score is positive 1, and so on. The area from the boundary of 0 to 1.00 of z-score is 0.3413, and that will be based on the value that can be seen in the table. This area is also the same if your value for z-score is negative 100. It's just that negative implies that your area is on the left side. So this area, enclosed area, is equal to 0.3413. From 0 to 2, this entire area is equal to 0.4772, as well as from 0 to negative 2.00, that is also equal to 0.4772. And then from 0 up to 3, that is 0.4987. Take note that it is the area from 0 up to this mark of 3.00. That means this area is simply the difference of 0.5, the total area of the right side or half of the normal curve, minus this area bounded by 0 up to 3, 0.4987. So that means this is 0.0013. Now let us now determine the area under the normal curve using the value of z-score. Let's say our z-score is 1.25, so we look for 1.2 here on this column, and the last digit 5 can be seen here on top of the table. So 1.2 is here, and the remaining 0.05 is here. So if the two values meet this value 0.3944, it means it is the area bounded by the curve from 0 up to the z-score 1.25. From 0 up to positive 1.25, the area is 0.3944. Let's say we have values for our x, our mean, and standard deviation. So you must first determine the value of your z-score. Using the formula for z-score, that is x minus mu all over the standard deviation, we substitute the values. Then we will get a value of negative 1.125. But since this is z-score, we must express our value in 2 decimal places. So we rounded up these to 2 decimal values, so we have negative 1.13. So the area bounded by 1.13 is 0.3708. The negative sign only implies that our curve or our area is on the left side of the. So this is our curve, and then the boundary and the area. And this shaded area or colored area is equal to 0.3708. Let us now use the concept of z-score and area under the normal curve in a particular situation. Let's say you would like to determine the IQ level of certain population, or the probability of those who have an IQ level between 105 to 100, wherein the mean is 100 and the standard deviation is 12. So let us first get the z-score, and that would be equal to 0.42. So this is our graph. This time the marks are the label of our mark markers are based on the values itself: 100, 112, 124, and 136. The difference is the value of our standard deviation 12. So these are the boundaries: 100 and 105. With the with the z-score of 0.42, if you look at the table, this area will be equal to 0.1628. We can interpret this value as 16.28% of the population has an IQ level between 100 to 105. So this area this area is actually can be used as probability. So if we're looking for the probability of the population who has an IQ of 105 to 100, you can use the area bounded by the two values as your probability. For our last example, let's say you would like to determine how many of the entire population have the age between 30 to 42 years old. If the mean age or the average age of the entire population is 42 years old and the standard deviation is 10. Since 42 is our mean and that is one of the boundaries, that means 30 will be our x. And now, let's just use these values to solve for our z-score. We will get a value of negative 1.20. So that means the area that we are going to identify is on the left side of the mean. So this is the graph, 42 at the middle because it is our mean. Since the standard deviation is 10, the difference between one mark to another is equal to 10. So these are the boundaries, 30 to 42. And based on the table of the area under the normal curve, the value of this area with respect to the value of 1.20 as our z-score is 0.3849. In percentage, that will be 38.49%. So that means 38.49% of the population has the age between 30 to 42 years old. So that is how we determine the z-score, the area using the table, and how to use area as probability using the area under the normal curve. So thank you very much for watching, and see you for the part 2 of this discussion on how to get the area under the normal curve and how to use it for as probability. See you again next time in our next video. Thank you.